Hi, today my lab partners and I will be presenting our experiment on the electrostatic forces. So this is the experiment that we conducted in our first laboratory session and this Tuesday. And very much we will be using very simple everyday objects to conduct this experiment, such as tape, and to explore the principles of electric charge. Um, so let's begin then. With the introduction, let's start with a quick review for the main concepts that we're investigating, which in this case, as mentioned, are electric charge. We all know from earlier science classes that the charge is a basic property of matter that comes in two types, positive and negative, right? The most important rule for us to remember today is that like every charges, like charges, those that are the same, such as positive and positive and negative, will repel each other, while different charges, such as which in this case is negative and positive, will attract each other. Another thing is that most objects around us are electrically neutral, which means that they have a balance between the amount of positive and negative charge. So the negative charge and the positive charge are equal, therefore they cancel each other and makes them neutral. And pretty much the goal for this lab is to disrupt that balance in the chips that we're going to use, giving it a negative or a positive or a negative charge, and observe what happens. And pretty much with that said, the main objective that we have for this experiment is to observe, test, and analyze these electrostatic interactions through this experiment.
Now, in this experiment, the materials are very simple. All we will need is a marker, clear tape, objects to test for charge, which we need 3 of in total. And optionally, you can use a yardstick. We ended up not using the yardstick for our experiment. For this experiment, our procedure was divided into 4 different parts labeled A through D. Now, to begin the experiment. For part 8, we were asked to cut a piece of transparent tape and fold a section at the end of it to make a non-sticky handle. We then stuck the tape onto our table, and we were instructed to pull vigorously on the tape. This was supposed to charge the tape. Next, we attached the tape onto the edge of a table, and we tried to test it with various different items. We tested a phone, a claw clip, and a pen. Now, moving on, for part B, we were asked to charge a new piece of tape in the same way as we did in part A, by attaching it to the table and then pulling vigorously in order to create a charge. Then, we stuck that newly charged piece of tape onto the side of our table. So as you can see from our videos, we made a couple mistakes. We ended up throwing away our piece of tape from part A, so we had to charge a new one. And then when we tried to test them, we ended up removing the piece of tape from the table. Now, moving on to part C. For part C, we charged a piece of tape following the same steps from part A and proceeded to place it on the edge of the table. We then took 2 additional pieces of tape and made handles on them by folding them at the end. We then stuck one of these pieces of tape onto our table and labeled it B for bottom. Then we pressed the second one directly on top of it and we put the letter T on it for top. As you can see here, we made another mistake because instead of stacking the 2 pieces of tape together, we charged each tape separately and tried to check for charge that way. Then, we peel both tapes as a single unit, we run our finger along the tape to remove the charge, and we test them for charge. Next, we peel both tapes apart by the handles and we hold each of them in one hand and test for an interaction between them. Now for the last part. For part B, we took the top and bottom tapes from part C and stuck them together. And then, all we have to do is test them for charge.
Hello everyone, my name is Zoe. This is the data and data analysis section of Lab Report 1. So we have 4 different sets of data that came from each part. So we're going to start off with part A, and within part A we were supposed to charge a single piece of tape and test it against different objects, and we saw attraction in 2 of the cases and 1 neutral, and we believe that that's partly due to like error and the charging process, but 2 out of 3 is not too bad. Then we can see that in part B, which is right below it, we can see that in this part of the experiment then we did 2 pieces of tape side by side, so this had nothing to do with objects, and then we put them closer together once they were charged, and the way that we charged them both was ripping them off of the table, and that is the same thing that we did to charge part A, as we held them closer to objects, and in this one we held it close to a piece of tape, and in this case both pieces of tape were positively charged, and when we put them closer together, as part B had stated, we saw them repel each other. We then move on to part C, which this is where we had 3 sets of tape, a new piece of tape, a top and bottom piece of tape, and what those whole new interactions were with an original piece of tape. And with the top piece, it was repelled when interacted with the new piece of tape, or the old piece of tape, and the bottom piece of tape attracted in the same manner. We can also see that with part D, which was when we finally combined the top and the bottom tapes back together, they became neutral, and this shows that the opposite charges can cancel each other out, and that the system, because it is both the same, they were both charged the same way, that they should have came out neutral. So overall, our results were pretty good based on this analysis. And the tiny little errors were probably due to charging errors on our end, and how we went about doing so, but overall pretty good. Thanks.
Following the completion of the lab, the team investigated the interactions the 2 charges, negative and positive, had amongst each other during the trial and errors with the tape. We learned the different interactions of the tape produced viable results. Our predictions rooted from a broad understanding of predicting the negative and positive charges for each respective part. We predicted part A's tape to be negative to attract each of our items tested, the hair clip, pen, and the phone, to be positive, thus showed slight interactions with the hair clip and the phone. One difference was how there was no notable visual interaction with the pen, which made to be neutral. In part B, the group predicted the tape to be slightly attracted to each other, though showing no interaction between each respective tape, hence both proving a positive charge amongst each other. In part C, we predicted the tapes to have an attraction towards each other. This was due to the charging of the tapes onto the table, while the opposing bottom tape having an opposite charge to attract one another. Once our team grew an understanding, we acknowledged the differences with the tapes once they had been attached and separated, then when the charges had been exchanged. This exchange produced an interaction of the tapes, of the top tape to repel and the bottom tape to attract the charges while they were being separated. In Part D, the team predicted the tapes to have a slight interaction with each other. Though following through the experiment, this showed the tapes to appear neutral with no attraction or repulsion. Overall, the team grew an improved understanding of the complexities of the charges and how each charge is transferred to each other, to each piece of tape and/or object. The lab provided a hands-on experience while also visually understanding negative charges from the tape pulled from the table and the positive charges from the opposing tape and objects.